With a programming-based approach, this course is designed to give you a solid foundation in the most useful aspect of digital signal processing in an engaging and easy-to-follow way. The goal of this course is to present practical techniques while avoiding obstacles of complex mathematical theories. To achieve this goal, the DSP techniques are explained in plain language, not just through mathematical derivations. Still keeping it simple, this course comes in different programming languages and hardware architectures so that students can put the techniques to practice using a programming language or a hardware architecture of their choice. This version of the course uses the Python programming language. By the end of this course, you should be able to develop the convolution kernel algorithm in Python, develop 17 different window filters in Python, develop the discrete Fourier transform algorithm in Python, develop the inverse discrete Fourier transform algorithm in Python, design and develop finite impulse response filters in Python, design and develop infinite impulse response filters in Python, develop Type I Chebyshev filters in Python, develop Type II Chebyshev filters in Python, develop Butterworth filters in Python. You will be able to perform spectral analysis on ECG signals in Python. You'll be able to develop Bessel filters in Python. Also, you'll be able to simulate linear time invariant systems in Python, even give a lecture on DSP, and so much more. In fact, there are over 70 examples in this course, so please take a look at the full course curriculum and I shall see you inside.